Hello students. So welcome back to my video lectures on solving multiple choice questions. Okay, from the third chapter of 11th standard, that is called as classification of elements and periodicity in properties. I think we have solved around 20 questions. Let us continue with the other questions. Okay, yeah. So where did we stop at? Okay, we have yes. So I think we have solved this question. Yeah, we have solved up to 22nd questions in the previous video. Okay, so we will continue with the 23rd question. Okay, so the 23rd question says, which one of the following grouping representations, which one of the following grouping represents a collection of isoelectronic species? Atomic number of cesium is 55, atomic number of bromine is 35. Okay, so which of the following grouping represents a collection of isoelectronic species? Okay, we have already known about isoelectronic species. Okay, by the way students, what do you mean by isoelectronic species? Okay, what do you mean by isoelectronic species? Okay, that means we know species having same number of electrons. Same number of electrons are called as what? Isoelectronic species. Is that correct? Okay, yeah. Let us take up this okay, we just have to choose a group. We have to choose a group which has same number of electrons. That means which has isoelectronic species. By the way, what is the atomic number of sodium? Yeah, atomic number of sodium is 11. On losing one electron, it has 10 electrons. Calcium, atomic number of calcium is 20. Okay, upon losing 2 electrons, okay, the number of electrons is going to be 18. That means they do not have same number of electrons. They do not have same number of electrons. Hence, option A cannot be the answer. Is it correct? Now, going on to the next option, nitride N3 minus. Nitrogen atomic number is 7. Okay, upon gaining 3 electrons, the number of electrons is going to be 10. Fluorine, okay, atomic number is 9. Upon gaining 1 electron, the number of electrons is going to be 10. Sodium, okay, just now, atomic number is 11. On losing 1 electron, it becomes 10. So, nitride has 10 electron, fluoride has 10 electrons, sodium has 10 electrons. So, don't you think, okay, they have the same number of electrons? Hence, therefore, can I say that they are isoelectronic? Hence, they are isoelectronic in nature. So, the correct option is option B. Simple, okay. So, what are isoelectronic species? The species having same number of electrons are called as isoelectronic species. Isoelectronic species. Okay, nitride, okay, atomic number of nitrogen is 7. On adding 3 electrons, 10. Fluoride 9. On adding 1 electron, 10. Sodium 11. On losing 1 electron, 10. They all have the same number of electrons. Therefore, they are isoelectronic with each other. Okay, hence it is option B. Okay, correct. Yeah. Okay, fine. Next question. The question says, K plus and Cl minus ions are isoelectronic. They itself have told that they are isoelectronic. Even if they don't tell, we itself can check. Is it? Okay. Potassium. Atomic number of potassium is how much? 19. Is it correct? Okay. Upon losing 1 electron, it becomes 18 electrons. Correct? Chloride. Atomic number 17. Chlorine atomic number 17. On gaining 1 electron, it becomes 18 electron. Therefore, they have same number of electrons. Since they have same number of electrons, they are isoelectronic with each other. So, K plus and Cl minus are isoelectronic. No doubt in it. Okay, because they both contain 18 electrons. Since they both contain 18 electrons, same number of electrons, they are isoelectronic with respect to each other. Which of the following statement is not correct? Both K plus and Cl minus contain 18 electrons. Yeah, it is correct. Okay, yeah, they have same 18 electrons and 18 electrons each. So, option A is correct. Both K plus and Cl minus have same configuration. Yeah, if the number of electrons are same, then definitely they're going to have same electronic configuration. Is it correct? What will be the electronic configuration of K plus? Look at here, K. Okay, electronic configuration of potassium 19, 1s2, 2s2, 2p6, 3s2, okay, 3p, yeah, 6, 4s, okay, yes, 4s, what? 1, but upon losing one electron it becomes 18, 4s 0. This is the electronic configuration of K plus. What will be the electronic configuration of Cl minus? Chlorine 1s2, 2s2, 2p6, 3s2, 3p5, chlorine 17. This is the electronic configuration. Upon gaining one electron it becomes 3p6, correct? So 1s2, 2s2, 2p6, 3s2, 3p6, 1s2, 2s2, 2p6, 3s2, 3p6. They have the same electronic configuration. 18 electrons, 18 electrons. So option B is also correct. Both K plus and Cl minus ions contain 18 electrons. That's correct. Both K plus and Cl minus ions have the same configuration. That is also correct. K plus ion is bigger than Cl minus ion. K plus ion is bigger than Cl minus ion? No. In one of my MCQ, I have given a clear-cut idea. You should always remember that always anions are bigger than cations. Okay, anionic size will be more than cationic size. Always anionic size will be more than what? Cationic size. That means chloride ion is bigger than what? Potassium ion. Chloride ion is bigger than potassium ion. So option C says K plus ion is bigger than Cl minus ion. No, cations can never be bigger than anions. Cations are always smaller than anions. So option C is not correct. How about option D? Chloride ions are bigger than K plus ions in size? Yeah, obviously. Okay, because anions are bigger than what? Cations. Since anions are bigger than cations, chloride is bigger in size than K plus ion. So option D is also correct. A is correct, B is correct, D is also correct. Then which is not correct? It is option C. Option C. Simple? That's good. Okay, let us move on to the next question. Yes, the next question says, the period number in the long form of the periodic table. This we have discussed in one of my video, okay, in a different way. Same question but has been asked in different ways. Same question but it has been asked in different ways. The period number in the long form of periodic table is equal to, I have already told you, okay, period number indicates okay, what? It indicates principal quantum number of, okay, valency shell, correct? Okay, principal quantum number means n value. Yes. So period number indicates the principal quantum number of the valency shell. Group number, what does group number indicates? Group number indicates the number of electrons in valency shell. Okay, the number of electrons in valency shell. Period number indicates the principal quantum number of valency shell, whereas group number indicates the number of electrons in the valency shell. So what is the correct answer for it? The period number in the long form of periodic table is equal to magnetic quantum number of any element of period? No. Atomic number of any element of the period? No. Maximum principal quantum number of element of the period, or maximum azimuthal quantum number of element of the period. Maximum principal quantum number means principal quantum number of the valency shell. Okay, because principal quantum number is maximum for outermost shell. Is it correct? Principal quantum number will be maximum for outermost shell. What is the principal? Yeah, okay. Yes, if I take sodium, okay, look here, atomic number 11. Its electronic configuration is 1s2, 2s2, 2p6, 3s1. Look here, this is the valency shell. For this shell, the principal quantum number is 1. For this shell, principal quantum number is 2. For this shell, principal quantum number is 3. Well, principal quantum number is maximum for the valency shell, and this principal quantum number is nothing but the period number. correct? So the period number in the long form of the periodic table is equal to maximum principal quantum number. Maximum principal quantum number. When do you say that the principal quantum number is maximum? Principal quantum number is maximum for the valency shell. Okay, therefore he is indirectly telling that the period number indicates the principal quantum number of valency shell. Okay, and always remember, principal quantum number of the valency shell will be maximum. Will be what? Maximum. Understood? Clear? Simple? Okay, great. So what is the correct answer for this? It is option C. Okay, period number in the long form of the periodic table is equal to maximum principal quantum number of, okay, element of the period. Yes, it's option C. Excellent. Okay, next question. Yes, next question. The element in which the electrons are progressively filled in 4f orbital are called as. One type of problem of such kind I've already finished in the previous video. The elements in which the electrons are progressively filled in 4f orbital. I told you, if the electrons are filled in f orbitals, whatever might be the f orbital, if the electrons are filled in f orbitals, then they are called as f block elements. Okay, f block elements, and we have two series in f block. One is lanthanoid series, the other one is actinoid series. Lanthanoid series and actinoid series. For lanthanoid series, 4f orbital is filled. For actinoid series, 5f orbitals are filled. Correct? Okay. For lanthanoid series, 4f orbital is filled. For actinoid series, 5f orbital is filled. The question is, the element in which the electrons are progressively filled in 4f orbital are called as what? Lanthanoids. Is it correct? Yeah. For actinoids, 5f orbital. For lanthanoids, 4f orbital. For transition elements, d orbitals. Okay. For halogens, p orbital. Okay, p orbital. Hence, what is the correct answer for it? The element in which the electrons are progressively filled in 4f orbital are called as lanthanoids. Lanthanoids. Okay. Yeah, students. So what's the answer for this? It is lanthanoids, 4f orbital. Okay. Yeah. Next question. Yes. The next question says, the screening effect of d electrons is. Did we discuss about the screening effect in the previous video? Did we? Yeah, we have already discussed about screening effect. Okay. What is screening effect? The electrons in the inner orbitals will cover the electrons in the outer orbitals from the nuclear force of attraction. Okay. The electrons in the inner orbitals. Yeah. Okay, I hope you remember, because I have already discussed about this. Okay. Yeah, the electrons in the inner orbital. Okay. The electrons, these electrons in the inner orbital will cover the outer electrons, from the nuclear force of attraction. Okay, that means nucleus will exert less force of attraction on these outer electrons because of these inner electrons, since they have covered the outer electrons. The nucleus cannot detect the outer electrons because they have been covered by the electrons in the inner orbitals. So this effect is called as screening effect or shielding effect. By the way, what is the order of shielding effect or screening effect? Okay, yes. So screening effect or shielding effect is more for the electrons in s orbital, then p orbital, then d orbital, and then f orbital. Okay, I have also told you that d orbital and f orbital will exhibit what? Poor shielding effect. They will exhibit poor shielding effect. Understood? Am I correct? Okay, yes. So now the question is, the screening effect of d electrons is equal to that of p electrons? No. Now the screening effect of d orbitals, the screening effect of d electrons is less than that of p electrons. Am I correct? Okay, yes, the screening effect of d electrons is less than that of p electrons. So what is the correct answer for it? It is option D. Yes, the screening effect of d electrons is less than p electrons. So wonderful. Okay, correct. Yeah, next question. Okay, the smallest among the following ions is, the smallest among the following ions. See, in case of ions, we know very well that anionic size is always more than that of what? Cationic size. That means the size of anions will be more than the size of cations. The size of anions is more than the size of what? Cations. Okay, but in the given question all of them are cations. We have sodium ion, magnesium ion, barium ion and aluminum ion. In the given question all of them are cations. Now how to judge whether the given ion is small or whether the given ion is big when all of them are same type of ions, when all of them are cations, when all the ions are anions, then how to judge? Now in that case please do remember this rule. What is that rule? Okay, higher the positive charge, okay, yes, higher the positive charge, higher is the effective nuclear charge, higher is the effective nuclear charge, higher the effective nuclear charge, smaller is the size. Please remember this way, smaller is the size. Are you getting my point? Okay, higher the positive charge, higher is the effective nuclear charge. So if the positive charge increases, okay, effective nuclear charge increases. If the effective nuclear charge increases, the size will decrease. Size will decrease. Okay, understood? So as the positive charge increases, effective nuclear charge increases. When the effective nuclear charge increases, size decreases. This is with respect to cations. Okay, take this as one rule. Anions size are more than that of cationic size. Among cations, higher the positive charge, higher is the effective nuclear charge and smaller is the size. In case of anions, higher the negative charge, higher the negative, I hope you can see this, higher the negative charge, okay, more is the repulsion, more is the electronic repulsion, and hence bigger will be the size. Bigger is the size. Okay, go for it. Understood? Okay, if the negative charge increases, that means when does the negative charge increases? Negative charge increases when the number of electrons increases. Is that correct? Okay, when the number of electrons increases, electrons will repel each other. When the electrons repel each other, the size will increase. So please remember these rules. Anions are bigger than cations. Among cations, if the positive charge is more, effective nuclear charge will be more, size will be less. Okay, among anions, if the negative charge is more will be the number of electrons. More the number of electrons, more is the repulsion. More the repulsion, bigger will be the size. Now, let us answer this question. Among the following, the smallest among the following, we have cations. This has 1 positive charge, 2 positive charge, 2 positive charge and 3 positive charge. Okay, which among them is smallest? Okay, use this rule. Higher the positive charge, smaller is the size. Am I correct? Higher the positive charge, smaller is the size. So which ion has highest positive charge? It is +3. Aluminium has highest positive charge, therefore it will have smallest size. So what is the correct answer for it? It is option D. So the smallest among the following ions is aluminium, ion. Simple? Okay, correct. Next question. Next question. The electron affinity for the inert gases. I think this is the third time we are discussing about the electron affinity for inert gases. Okay, yeah. So inert gases means, inert gases are nothing but what? Noble gases, correct? Inert gases are nothing but noble gases. Am I correct? Yes, noble gases. I have told you noble gases have stable configuration. Stable configuration. What is the stable configuration of noble gases? It is, okay, NS2, NP6. Okay, since they have stable configuration, they have already attained octet structure. They have stable configuration. Okay, what is your inference? It is very difficult, okay, to remove an electron, and also it is difficult to add an electron. Okay, it now from the stable configuration, it is difficult to remove an electron and it is also difficult to add an electron. We cannot remove electron or we cannot add electron to a stable configuration. If we can't remove an electron, then okay, ionization enthalpy is highest. Ionization enthalpy is highest. If we can't add an electron, then electron gain enthalpy is least. Please remember this. Okay, if you can't remove an electron, then ionization enthalpy will be highest. Okay, yes. So among all the elements of the periodic table, noble gases have highest ionization energy, or noble gases have highest ionization enthalpy. And also it is difficult to add an electron to noble gases. Is it correct? That is why, okay, noble gases have least electron affinity, or noble gases have least electron gain enthalpy. Okay, hence since they have least electron gain enthalpy, the electron gain enthalpy of noble gases, don't say it as 0, okay, it is always positive. Electron gain enthalpy of noble gases is positive, whereas for other elements, the electron gain enthalpy is usually negative. Electron gain enthalpy is negative for other elements. Only for noble gases, electron gain enthalpy is positive because it is very difficult to add electrons to noble gases. Okay, so answer this question. The electron affinity, nothing but electron gain enthalpy, one and the same. The electron affinity for the inert gases, is it 0 or is it high, negative or positive? Yeah, okay, electron affinity for the inert gases is always positive. Understood? Yes. Okay. Yes. Next question. Okay, well, this question has been asked in Karnataka CET 2014. See how simple it is. Among the elements from atomic number 1 to 36, the elements which have unpaired electrons in their s subshell is, the number of elements which have unpaired electrons in their s subshell, okay, yes, the question is very clear. Okay, you have to consider the elements from atomic number 1 to 36. Okay, so we have got so many elements, say hydrogen, okay, helium, lithium, okay, beryllium, okay, boron, carbon, nitrogen, oxygen, fluorine, neon. Okay, so we have got so many elements. Look at here, let us go back to let us use the periodic table for it. Okay, 1 to 36. Okay, look at here. So 1, we have hydrogen, helium, lithium, beryllium, boron, carbon, nitrogen, oxygen, fluorine, neon, sodium, magnesium, aluminum, silicon, phosphorus, sulfur, chlorine, argon, okay, potassium, calcium, scandium, titanium, vanadium, chromium, manganese, iron, cobalt, nickel, copper, zinc, gallium, okay, then germanium, arsenic, selenium, bromine and krypton. Is it correct? Yeah, krypton. So from atomic number 1 to atomic number, okay, atomic number 36, how many elements have, okay, how many elements have unpaired electrons in the s subshell? How many elements have unpaired electrons in the s subshell? Okay, look here, see, if you consider, okay, alkali metals, what will be the general outer electronic configuration? Okay, for alkali metals it is ns1, for alkaline earth metals it is ns2, okay, and for d block elements, all the d block elements, okay, yes, they have completely filled s electrons, they have completely filled s electrons, okay, even, okay, p block elements also, p block elements also, they have completely filled what? S electrons, okay. Only alkali metals have, okay, half filled, okay, s orbitals in their valency shell. How many number of valence electrons from 1 to 36? It is only hydrogen, lithium, sodium and potassium. Hydrogen, lithium, sodium and potassium. Is it okay, 4 elements? Let us check. Okay, let us check. Let us check it out. Just a minute. Okay. What question is it? Yeah, among the elements from atomic number 1 to 36, the number of elements which have unpaired electron in the s subshell is only 4. Is it correct? Which are those? Hydrogen, lithium, sodium, potassium. So how many elements altogether? It's, okay, 4 elements. It is option C. Option C. Yes, excellent. Okay, that's correct. Yes. So let us move on to the next question. Yeah, okay, let's go with next question. I don't know why this is not working. Yes, that's great. Okay, yes, it is now working. Okay, among the elements from atomic number 1 to 36, the number of elements which have unpaired electron in their s subshell is 4. Correct. Okay, next question. The correct arrangement of ions in the increasing order of their radii is. Again, this question has been asked in Karnataka CET 2014. Please emphasize on all these problems. Okay, the correct arrangement of the ions in the increasing order of their radii is. Okay, didn't I tell you that? Okay, anions are bigger than cations? Yes. Increasing order, they have given increasing order. The correct arrangement of ions in the increasing order of their radii. Okay, now you should think, you should always remember, anions are bigger than cations. Okay, so higher the negative charge, higher is the size. Remember this. Higher the positive charge, smaller is the size. Okay, please do remember. Now going on to the first option, we have Ca2 plus, K plus, S2 minus. Ca2 plus, okay, K plus and S2 minus. Is that correct? Yes, of course. Okay, anions are bigger than cations, and higher the positive charge, smaller is the size. Therefore, obviously, sulfide is bigger than K plus is bigger than Ca2 plus. Is this in the increasing order? Yes, this is in the increasing order of their radii. Exactly. Then option A itself is correct. Option A itself is correct. The correct arrangement for the ions in the increasing order of their radii. If I go with the second question, okay, see, we have chloride, fluoride and sulfide. See, fluoride and chloride, okay, belong to the same group. Okay, so down the group the size should increase. We know that. Down the group the size will increase. That means chloride should have bigger size than fluoride. Is it? Because down the group the ionic size will increase. So therefore chlorides will have bigger size than fluoride. So okay, according to this, sulfide has bigger size than fluoride, fluoride has bigger size than chloride, which is absolutely wrong, because sulfide, okay, look at here, higher the negative charge, this has -2 charge, this is -1. So higher the negative charge, higher is the size. Higher is the size. Therefore, obviously, sulfide is bigger than chloride and fluoride. But among fluoride and chloride, which is bigger? Yes, chloride is bigger than fluoride. Why? Because down the group, ionic size will increase. Hence, this is wrong. Okay. Yes, this is also wrong. This is also wrong. The correct increasing order of their radii is option A. Direct question, Karnataka CET 2014. Such a simple question. It is based on this simple rule. It is based on simple rule. Okay, correct? Yeah, excellent. Okay, yes, next question. Yeah, let us move on to the next question. Okay, yeah, again 2015, quite tricky. The question is quite tricky. What does the question says? For one of the element, various successive ionization enthalpy in kilojoules per mole are given below. Okay, for one of the element, various successive ionization enthalpies are given below. First ionization enthalpy is 577.5 kilojoules per mole. Second ionization enthalpy is 810 kilojoules per mole. The third ionization enthalpy is 2750 kilojoules per mole. Fourth is 11580 kilojoules per mole. Fifth is 14,820 kilojoules per mole. Okay, observe, for one of the element, various successive ionization enthalpies are given below. Okay, first ionization enthalpy, second ionization enthalpy, third ionization enthalpy, fourth up to fifth. They have given up to fifth ionization enthalpy. So, based on this ionization enthalpy, you have to identify which element is that. Okay, is it silicon or phosphorus or aluminium or magnesium? Silicon or phosphorus or aluminium or magnesium. Let us write the electronic configuration for them. Okay, observe this ionization enthalpies here. First ionization enthalpy is just 577.5 kilojoules per mole, whereas second ionization enthalpy has increased to a lot. Okay, no, it is just 577.5. okay, it is 1810. It is almost how many times? 3 times. Okay, the second ionization enthalpy is almost 3 times the first ionization enthalpy. Okay, no, but the third ionization enthalpy has not increased so much. It has not increased so much. Okay, whereas look at the fourth ionization enthalpy. Fourth ionization enthalpy is very much higher than what? Third ionization enthalpy. Okay, fourth ionization enthalpy is 11,580 kilojoules per mole, whereas third ionization enthalpy is just 2,750 kilojoules mole. Okay, now there is no much increase in the fifth ionization enthalpy also. Look here, just compare the first and second ionization enthalpy, third and fourth ionization enthalpy. There is a large increase in ionization enthalpy from first and second. Okay, there is a large increase in ionization enthalpy from third ionization enthalpy to fourth ionization enthalpy. There is a very large increase in the fourth ionization enthalpy. There is a large increase in second ionization enthalpy also. Then you have to identify which element is it. Is it silicon or phosphorus or aluminium or magnesium? Okay, let us see. For silicon, what is the atomic number of silicon? What is the atomic number of silicon? Come on, carbon, silicon, carbon 4, 4 plus 8. 4 plus 8. Come on, how much? Okay. Yeah. Carbon, silicon, germanium. Okay. Sorry, carbon, silicon. Okay. Germanium, tin, lead. Atomic number of carbon is 6. 6 plus 8, okay, is how much? 6 plus 8 is 14. Okay, so the atomic number of silicon is 14. Let us write its electronic configuration. 1s2, 2s2, 2p6, 3s2, 3p4, correct? Sorry, 3p2, 3s2, 3p2, isn't it? 3s2, 3p2, 1s2, 2s2, 2p6, 3s2, 3p2. Okay, let us keep on removing the electrons. 1 electron, 2 electron, 3 electron, 4 electrons. Okay, so I'll remove 1 electron, it becomes 3p1. Okay, now I'm going to remove one more electron, it becomes 3p0, second ionization enthalpy. Remove the third electron, the third ionization enthalpy. Remove the fourth electron, fourth ionization enthalpy. Remove the fifth electron, fifth ionization enthalpy. Okay, now if you go for phosphorus, what is the atomic number of phosphorus? 15. What is its electronic configuration? 1s2, 2s2, 2p6, 3s2, 3p3. See, for phosphorus, the first ionization enthalpy cannot be so much, so less. Okay, phosphorus will have first ionization, very high first ionization enthalpy. They will have first very high first ionization enthalpy. Why? Because if I have to remove one electron, okay, remember, so what do you mean by first ionization enthalpy? Removal of first last electron. Removal of second last electron is second ionization enthalpy. Next removal of the third electron is third ionization enthalpy. Removal of the fourth electron is fourth ionization enthalpy, and removal of the fifth electron is fifth ionization enthalpy. Well, okay, so look here, phosphorus has half filled p orbital. Half filled p orbital. We know half filled and completely filled atomic orbitals are half filled and completely filled atomic orbitals are completely filled, okay, atomic orbitals are highly stable, isn't it? Half filled and completely filled atomic orbitals are highly stable. Remember this, half filled and completely filled atomic orbitals are highly stable. That means this is a stable configuration. We know it is difficult to remove an electron, and also it is difficult to add an electron from stable configuration. If by chance, if I have to remove an electron from the stable configuration, I have to supply very high energy. Therefore, 577.5 kilojoules would not be sufficient. It is so less. Such a less energy cannot remove an electron from the stable configuration. Therefore, phosphorus can never be the answer. Okay, because first ionization enthalpy is so less, but for phosphorus first ionization enthalpy will be very high, because we have to remove electrons from stable half filled configuration. Are we clear? Yes. What about aluminium? Atomic number of aluminium is 13. What is its electronic configuration? 1s2, 2s2, 2p6, 3s2, 3p1. Is that correct? Now, okay, what is going to happen? Okay, yes, let us remove one electron. Okay, 3p0. Now, if I have to remove one more electron, that is about second ionization enthalpy, I have to remove from a completely filled atomic orbital. Just now I told you, half filled and completely filled atomic orbitals are highly stable. I can remove first electron easily. No doubt in it, first ionization enthalpy. But if I have to remove the second electron, that is the second ionization enthalpy, okay, now look at here, okay, I have to remove the second electron from a stable configuration. Half filled and completely filled atomic orbitals are stable. This is completely filled, it's a stable configuration. So in order to remove the second electron, I have to supply very high energy. That is why the second ionization enthalpy has increased from 577.5 to 1810. Okay, first ionization enthalpy was less, you require just less energy to remove the last electron, but in order to remove the second electron, you require very high energy. Why do you require very high energy? Because we have to remove electron from the stable configuration. So that is why the second ionization energy is very high. Okay, so now I have removed second electron also. Let us remove the third electron. Yes, I can remove the third electron also. But look at, in order to remove the fourth electron, From where I have to remove the fourth electron? I have to remove the fourth electron from an highly stable configuration. Don't you think it's a noble configuration? Noble gas configuration? Yes, it is a noble gas configuration. We know it is very, very, very difficult to remove the electrons from noble gas configuration. So I have to remove the fourth electron from a very, very, very stable noble configuration. That means I require very, very, very high energy to remove the fourth electron. That is why the fourth ionization enthalpy is very, very, very high. How much it is? 11,580 kilojoules. 11,580 kilojoules. Such a high energy because I have to remove the fourth electron from a noble gas configuration. Hence, these ionization energies are nothing but the ionization energy of aluminium. Is that simple way? Okay, first electron I can easily remove. Look at here. First electron I can easily remove. Yes, but for the second electron I should remove it from a stable configuration, so require high energy. That is why second ionization enthalpy has increased. Now, third electron can also be easily removed, but for the removal of the fourth electron should be removed from a noble gas configuration, which is extremely difficult. That hence very high energy, not just ion, very high energy is required for the removal of the fourth electron. That is why the fourth ionization energy is very, very, very high. How much it is? 11,580 kilojoules. Hence the answer has to be aluminium. Okay, any doubts with this? So nice. Okay, yes, clear? Excellent. Okay, next question. I'll move on with the next question. What does the next question says? Yeah, again CET, Karnataka CET 2017. Okay, the electronegativities of carbon, nitrogen, silicon and phosphorus are in the order. The electronegativities of carbon, nitrogen, silicon and phosphorus. So we have carbon, nitrogen, silicon and phosphorus. We have to arrange them, okay, in the order of electronegativities. Let us write these elements like the way it is, they appear in the periodic table. So first we have carbon, below which we'll find silicon. After carbon we'll have nitrogen, below which we'll find what? Phosphorus. We know, okay, electronegativity increases along the period, whereas electronegativity decreases down the group. Is that correct? Decreases down the group. Electronegativity increases along the period. Are they talking about electronegativity? Yes, they're talking about electronegativity. Electronegativity increases along the period. Electronegativity decreases down the group. That means from carbon to nitrogen, electronegativity increases. From silicon to phosphorus, electronegativity increases. But from carbon to silicon, electronegativity decrease. From nitrogen to phosphorus, electronegativity will decrease. So what is the order? What is the order? Can you please tell me? Okay, yes. Come on, what is the order? So can I say nitrogen has more electronegativity than phosphorus? Phosphorus has more electronegativity than carbon. Carbon has more electronegativity than silicon. Is it correct? Yes, like this. Yes. So obviously nitrogen family elements, look here, carbon, silicon, nitrogen and phosphorus. Nitrogen family elements are more electronegative than carbon family. Among carbon family, carbon is more electronegative. Among nitrogen family, nitrogen is more electronegative. So what is the order? Yeah, nitrogen is more electronegative than phosphorus. Phosphorus is more electronegative than carbon. Carbon is more electronegative than silicon. Okay, hence the correct order is nitrogen. Okay, yes. So look here, just a reverse way of it. Nitrogen is more electronegative than carbon. Carbon is more electronegative than phosphorus. Phosphorus is more electronegative than silicon. Okay, you have to go in a zigzag way. Look at here. Nitrogen is more electronegative than carbon. Okay, yes. Carbon is more electronegative than phosphorus. Phosphorus is more electronegative than Silicon, a zigzag way, okay, because electronegativity along the period increases, down the group decreases, isn't it? So nitrogen is more electronegative than carbon is more electronegative than phosphorus is more electronegative than silicon. What is the correct answer for it? Yeah, okay, yes, excellent, it is option D. Nitrogen is more electronegative than carbon is more electronegative than phosphorus is more electronegative than silicon. Yes, excellent. Therefore, the answer is option D, zigzag manner. Okay, remember this rule always. Please remember this. Okay, along the period, electronegativity increases, down the group, electronegativity decreases. Okay, yes, excellent. Yeah, next question. Okay, the question says the nuclei of an alkaline earth metal undergoes radioactive decay. A nuclide of an alkaline earth metal, okay, undergoes a radioactive decay by emission of 3 alpha particles. By emission of what? 3 alpha particles in succession. The group of the periodic table to which the resulting daughter element would belong is, okay, it has been asked in, okay, All India Pre-Medical Test 2005. Okay, quite simple, quite logical based. And a nuclide of alkaline earth metal undergoes radioactive decay. Okay, which is alkaline earth metal which is radioactive in nature? Any idea? Which is the alkaline earth metal which is radioactive in nature? It is nothing but radium, isn't it? Okay, the alkali metal which is radioactive in nature is francium. The alkaline earth metal which is radioactive in nature is radium. Okay, a nuclide of alkaline earth metal undergoes radioactive decay by emission of 3 alpha particles. So that means this radium will undergo radioactive decay. It will undergo decay process and it emits 3 alpha particles. After emitting 3 alpha particles, which is the resultant daughter nuclei, which is the resultant daughter element. Okay, so yes, once again read out the question, understand the question. A nuclide of alkaline earth metal undergoes radioactive decay by the emission of 3 alpha particles in succession. The group of the periodic table to which the resulting daughter element would belong to. Okay, he is telling that radium is undergoing radioactivity. The only element which is radioactive, the alkaline earth metal which is radioactive is radium. It is undergoing decay process. It is undergoing decay process. When it undergoes decay process, they are telling that they are emitting 3 alpha particles in succession. Okay, and what is the resultant element? Which will be the resultant element after emitting 3 alpha particles? What do you mean by alpha particles? Alpha particles are nothing but nucleus of helium. Alpha particles are nothing but nucleus of helium. Okay, so radium has emitted 3 alpha particles in succession. After emitting 3 alpha particles, what is the residue that is left out? Which is that element that is left out? Okay, let us go back to the periodic table. Let us go back to the periodic table. Yes, look at here, radium. Okay, so this is the radioactive element. So radium, what is its atomic number? 88. So it is emitting 3 alpha particles in succession, means after emitting 3 alpha particles means, what do you mean by alpha particle? It is nothing but nucleus of helium. Okay, He24. Okay, 3 2s are 6. Okay, so the atomic number is reduced by 6. Okay, the atomic number is reduced by 6. Okay, if I take out 6 from 88, it's going to be X82. Which is the element with atomic number 82? The element with atomic number 82, can you find? Where is it? Yeah, it is nothing but lead. Yeah, okay, yes. So it is emitting 3 alpha particles. Please remember, 3 alpha particles. Alpha particles are nothing but nucleus of helium. It is emitting 3 alpha particles. That means the atomic number is reduced by how much? 6. 88 minus 6 is 82. So the element, okay, the resultant element will be, okay, the element with atomic number 82. Which is the element with atomic number 82? It is nothing but lead. And lead belongs to which group? Lead belongs to, okay, yeah, lead belongs to which group? Yes, carbon family. Carbon family means 14th group. Am I correct? 14th group. Okay, yes. Now answer that question. Yes, this is okay. So the resulting daughter belongs to group 14. So can I write the reaction like this? Radium 88 upon losing 3 alpha particles. 3 alpha particles are nothing but, okay, nucleus of helium. Okay, 3 2s are 6. So 6, okay. Now atomic number is reduced by 6. So which is the element whose atomic number is 82? It is lead. Lead belongs to which group? Okay, lead belongs to 14th group. 14th group. Okay, so the answer for this question is option A. Yes, excellent. Okay, next question. Yes. Yeah, it is from All India Pre-Medical Test 2005. Which one of the following arrangement represents the correct order of electron gain enthalpy with negative sign, okay, of the given atomic species? Okay, which one of the following arrangements represents the correct order of electron gain enthalpy? This I have already told. We have oxygen, sulfur, fluorine, chlorine. Okay, yes, I told you, go in a zigzag way. What is that? Okay, chlorine has more electronegativity than fluorine. Okay, and fluorine has more electron gain enthalpy than sulfur, and then oxygen. And then oxygen. Therefore, you have to remember this because I have already finished this problem. Okay, electron gain enthalpy of chlorine will be more than fluorine, more than sulfur, more than oxygen. This is the order. This is the order. Okay, please refer to my previous video. There you will get my explanations why this is the order. Okay, so you have to go in zigzag way. Zigzag way. The electron gain enthalpy of chlorine is more than that of fluorine, more than sulfur, and more than oxygen. This is the order. Hence the correct order is, yeah, it is option B. Chlorine more than fluorine, fluorine more than sulfur, sulfur more than oxygen. Yes, it is answer B. Okay. Yes, next question. Okay, which of the following orders, this type of question is quite important, very important. Okay, which one of the following order is not in accordance with the property that is stated against it? Okay, read the question carefully. Which one of the following orders is not in accordance with the property stated against it? Fluorine greater than chlorine, greater than bromine, greater than iodine. It is oxidizing power. Hydrogen iodide, okay, greater than hydrogen bromide, greater than hydrogen chloride, greater than hydrogen fluoride. It is acidic property. Fluorine greater than chlorine, greater than bromine, greater than chlorine, iodine, electronegativity. Fluorine greater than chlorine, greater than bromine, greater than iodine. Yeah, it is bond dissociation energy. Okay, look here. Option, yes, is not in accordance. The question is which is not in accordance. See, of course, if I take the first option, yeah, fluorine is a strong oxidizing agent than chlorine. Chlorine is a strong oxidizing agent than bromine. Bromine is a strong oxidizing agent than iodine. This is in accordance with oxidizing power. Correct. Next, of course, hydrogen iodide is a strong acid than hydrogen bromide. Hydrogen bromide is a strong acid than hydrogen chloride. Hydrogen chloride is a strong acid than hydrogen fluoride. So this is also correct. Yes. Yeah, next question is also, next option is also correct. Fluorine is more electronegative than chlorine. Chlorine is more electronegative than bromine. Bromine is more electronegative than iodine because down the group, electronegativity decreases. Very simple. So this order is also correct. Therefore, this is supposed to be wrong, is it? Yeah, fluorine, the bond dissociation energy of fluorine is more than chlorine, more than bromine, more than iodine. No, it's wrong. What is the actual order? The bond dissociation energy. Bond dissociation energy okay, is in the order, look here, chlorine has more bond dissociation energy than fluorine, which has more bond dissociation energy than bromine, than iodine. Okay, remember, okay, or else I can also write it like this. Chlorine has more bond dissociation energy than bromine, more than iodine, more than fluorine. Fluorine has least bond dissociation energy. Fluorine has least bond dissociation energy. That is why fluorine is highly reactive. Okay, highly reactive. That means I can break the bond between the two fluorine easily. That is why, okay, it has least bond dissociation energy. It is easy to break the bond. It is easy to break the bond between two fluorine atoms. Okay, hence, okay, very less energy is required to break the bond between two fluorine atoms. That is why it has least bond dissociation energy. Hence, fluorine is highly reactive. Fluorine is highly reactive. Okay, so this is the actual order, but they have given this order, hence this is not correct. So answer is option D. Excellent. Okay, next question. Here, okay, identify the correct order of the size among the following. Identify the correct order of the size among the following. Again, they have cations and they have anions. Cations and anions. Okay, what is the order? Anions are bigger than, okay, neutral atoms. Are bigger than neutral atoms, and neutral atoms are bigger than cations. Is that correct? Yes. Anions are bigger than neutral atoms. Neutral atoms are bigger than cations. Cations will have least size. Anions will have, okay, large size. Among anions, okay, higher the negative charge, okay, more is the size, isn't it? Among cations, okay, higher the positive charge, less will be the size. Okay, more the positive charge, lesser will be the size. More the negative charge, more will be the size. So now we have calcium, potassium, argon, chloride and sulfide. Yes, these are anions. This is neutral. Okay, and these are cations. Obviously, anions have bigger size than neutral species. Neutral species have bigger size than cations. Follow this. Okay, so anions are bigger than neutral, neutrals are bigger than cations. Now among anions, higher the negative charge, higher is the charge. So this has -2 charge, this has minus charge. So here, higher the negative charge, higher is the size. Okay, how about cations? Higher the positive charge, lesser is the size. This has +2 charge, this has plus charge. So this has higher positive charge. That means this has less size than K+. So what is the correct order? Yeah, sulfide has more ionic size than chloride, then argon, then potassium, then calcium. So hence the correct answer is, it is obviously option A. Option A. Remember this. Okay. Yeah, look at there. It has been asked in All India Pre-Medical Test 2007. Okay. Is that simple? Okay. Next question. So time ಎಷ್ಟಾಗಿದೆ ನೋಡಿ. Okay, students, I'll continue with solving these problems on this chapter in the next video also. Thank you so much.